Hello, and welcome to the Six Figure Developer Podcast, the podcast where we talk about new and exciting technologies, professional development, clean code, career advancement, and more. I'm John Calloway.
I'm Clayton Hunt. With us today is Dave Fancher. Dave is the lead software engineer at Vibenomics, speaker, blogger, author, and former Microsoft MVP. Welcome, Dave.
Hi, guys.
So, why don't you tell us a little bit about yourself and how you got started in the industry?
Sure. So I've been in the industry professionally, depending on where I start counting, from about 18 years now. Most of my career was spent on Microsoft technologies. I've been around computers my whole life, so I think it was about probably 4 or 5 years old when my dad brought home a PC Junior. And as a 5-year-old, I didn't care. But sure enough, I watched him doing software. He was in law and had developed some software for some of his job. And so, kind of got to see him programming. He was doing debugging back before we had good debuggers. And so I remember him poring over tractor feed paper, trying to find the missing the missing syntax elements. And I think he was using Quick Basic at the time. So a lot of exposure throughout life. Again, at that age, I didn't really care, but then I got interested in computers around middle school, teenage one-upsmanship. My friend comes over and says, "Hey, man, I made my computer count to 10," and hey, he discovered a for loop. And little did we know that little back and forth battle of, hey, look, I made it do it to 100 by fives. That kind of spiraled into the career. So like I said, I've been in Microsoft technologies most of my career. Came up through some QBasic and then went into Visual Basic. Then Microsoft released this thing called .NET, which shifted me over to C# for quite some time. And then a number of years ago, I started getting really frustrated with C#. I mean, the company I was working for had a bad habit, and probably the worst case of not invented here syndrome that I've ever seen. And I found that I had a whole bunch of really great skills that weren't applicable anywhere else. And I started re-examining things. Like I said, I started getting some frustration with C#. It felt like I was just repeating myself a lot. And that's about the time Microsoft had released LINQ. And they say LINQ is the gateway drug for functional programming. And it absolutely was for me. It was one of those things that just matched the way I think. And from there, I spiraled into the world of functional programming. I started putting terms to these things that I really liked in LINQ and understanding what higher order functions were, those types of things. And then I started discovering that there are languages like F# and Haskell and a variety of others that allow us to program in a way that, again, really more closely matched how I thought. And about that same time, I get into F# and I start seeing more functional features added into C#. So then all of the things I learned in F#, I was able to start applying into my C# code. And then about 3.5 years ago, my career took a very unexpected turn. I was doing some contract work and fell in love with a company that I had signed up on and ended up going full-time. And I found myself suddenly doing node development full-time. So being a functional programmer or falling primarily into the functional paradigms, as it was, I found myself in a very strange land. And if I was back at those times, I'm thinking how much has changed over the years. If I had to do what I'm doing today in, say, ES5, I think I might have quit and gone and farmed somewhere. So very long-winded ways of saying, I've been programming for a long time, and I've run the gamut of the paradigms.
So what are you working on these days?
So these days, you said in the intro, I'm working for a company called Vibenomics. We're out of Fishers, Indiana. We're really about audio out-of-home marketing. So we're kind of point of sale marketing. We allow advertisers to reach customers at the point of sale, as opposed to you're listening to a Spotify or a Pandora and getting bombed with ads. We're trying to hit you at the cash register.
Okay. Yeah, and when we met a number of years ago, I know that you were at that time pretty deep into F#, and I know that you mentioned in your intro here that you've been kind of grew up more recently in the functional programming side, and even have a couple of different courses on Plural site about functional programming. What is it, do you think, that just kind of diving a little bit more into that kind of got your interest, and what was it that you were working on at that time that you fell in love with F#?
So yeah, I'll go back to kind of that diving into Link at the time, right? I mean, you think about your normal C# project. You're defining your class. I mean, you're not even just C#. You do any object orientation. You're defining your classes and your structs and your namespaces, and trying to lay out all the properties, and dealing with visibility, all of your scoping, and just there's so many things going on, right? And you're telling the compiler something that it already knows 3, 4, 5 times. It was an episode of Hansel Minutes I was listening to at the time, and I wish I could remember the episode or the guests, but one of the things that really stuck with me, and was something that had been kind of going in the back of my head, was that object-oriented programming is kind of like filling out government forms in triplicate, right? You've got a variable type, but the variable is really just getting its return, is just getting populated with something that's from a function, and that function knows what data types it's working with, right? So why do I have to keep telling the compiler the same thing I've already told it over and over? Like, I grew up being told that computers are good at remembering things and doing the same thing over and over. So why is programming not like that? And as C# was evolving to get things like Link, and as F# was starting to get some interest, and I was learning about those, I started seeing the things like C# now has things like the var keyword, which gives us type inference. And oh, guess what? That's just built in naturally. That's just the way that F# works. So things like that, understanding, like, I've already defined this once, and the compiler is now intelligent enough to know what I've given it in this place, so now it can use it over here as well. Those types of things resonated with me, but it was also more than that. And it was things like changing the focus of our code. Am I going to continue thinking about the state of things and worrying about whether, if I change this block of code over here, that it's going to affect something in some seemingly unrelated part of the system? And I started thinking about these things, and started to understand in the functional paradigm that it's a complete change of focus. You're no longer thinking about shared state. You're no longer thinking about all of the complexity that comes with that. You're thinking in terms of inputs, outputs, and how to get from A to B. And that, to me, when I started looking at the things like the various Link expressions, that's all it was. It was, I have A, I need B, how do I get there? And so changing my focus changed the way that I approached writing software.
So with that, could you take a second and attempt to explain to the audience, for the uninitiated, what functional programming is, like, at its core? Not all the little details, but just the core of it.
Sure. So functional programming at its core, it's hard to nail down a specific agreed upon definition, but there's a couple of characteristics that always come up. First is things like immutability. Not having that shared state. If you can't change it, nothing can go wrong with it, right? There's the notion of referential transparency, where you can replace a function call with a value, and you're not going to affect the behavior of your software. There's concepts like, now I'm drawing a blank. There's the concepts of first-class functions, right? Being able to pass around a function like you would an integer or a string, being able to use them as input to a function or output from a function. So those are some of the kind of common constraints, right, or common themes that occur in functional programming.
All right. And you already mentioned that one of the things that drew you to functional programming was the feeling that you were constantly repeating yourself, either by having to redefine an object type that was being used, or rewriting the same code over again. How does functional programming alleviate you from those issues?
Sure. So in a lot of the more popular functional languages, first off, you'll find things like the type inference. I mean, that's an easy, quick win. But where it starts getting very more interesting and really gets you away from some of that repetition is one of the things that gets emphasized kind of by default, by the very nature of the paradigm, is things like in the solid principles, single responsibility, do one thing. You're going to write small focused functions. And because you're thinking about things in terms of how do I get from A to B, you're going to make that they're naturally going to be smaller. You're going to write smaller functions. They're going to do that one thing naturally. Well, now if you have immutable data and you're not sharing data outside of those, the areas of functional purity, impure meaning that it has some outside influence versus pure, which doesn't change your state. When you start following those patterns, you fall into a rhythm of, oh, I've written this one thing. It's very small. It's very concise. It's very focused. And oh, by the way, I can more easily compose it with other things. And because it's not tied inherently to some class necessarily, I can just naturally bring something that I wrote in one place and thinking in generalities, hey, I solved this problem once before. It's accessible to me. I can use it over here instead and not have to worry about increasing my code footprints and my code base size because I've already implemented that particular functionality. Now I'm dealing with a closer notion to functions as Legos.
So you just, with all of those functions broken down, you can just stack the bricks and get the outcome that you need.
Right, exactly. And I follow this all over the place. And I've got code in my current project that just allows me to, it's JavaScript is what I'm working in these days. Like JavaScript, what is our basic, going back to our basics of JavaScript, what is our fundamental unit of organization? How do we hide things away? Well, we wrap it in a function. And more modern JavaScript hides some of that from us. We get modules, but behind the scenes, what is it really? It's syntactic sugar on a function. So when we start thinking about these pieces that we can just bring together and, oh, if I'm passing functions around, well, now I can compose them in such a way that I can get brand new functions from these smaller modularized pieces.
Yeah, and you had mentioned that I guess 3 years ago or so you switched over to Node and doing a lot of work. Excuse me, and doing a lot of work in JavaScript. What does I would imagine bringing your functional flavor into JavaScript? What does functional flavored JavaScript look like as opposed to the JavaScript that the rest of us know and love and write?
Okay, so yeah, it's a very different way of approaching JavaScript, and it's things that have been possible for a long time, but the way that I've approached it is I brought in things like ES6 symbols, right? For those not familiar with an ES6 symbol, it allows us to add members to a type without running into the problems of potential name conflicts because they're guaranteed to be unique. So coming from a more .NET background, I got really used to things like extension methods. Well, it turns out that I can do essentially an extension method in JavaScript with a symbol and not have to worry about something else stepping on it. So I use a lot of extension methods, essentially, if you will, symbol-based members on an object to extend some prototypes without running into those collisions. And that opens up worlds of possibilities.
So I haven't used symbols very much, but I do know that you can't just call a symbol by name. The names are fundamentally unique, right? So how do you access these symbol extensions on a function? Do you have to create like a symbol library or something?
essentially a symbol library. I've got several modules that export those names. So treating them like variables. Essentially, they're imported where I need them, and then they're visible. So using the bracket syntax for member access, I can access the function that is exposed under that symbol.
Okay.
So the symbol correlates to a member, and that member happens to be a function.
Okay. So are you, so in JavaScript, the heavy lean for the last 4 or 5 years has definitely been towards object-oriented from the language perspective, whereas libraries like React have been leaning heavily towards functional, kind of contradicting the direction that the language seems to be trying to go. Are you using objects at all in your programming, or are you sticking with like raw?
I go the extreme of avoiding formal objects wherever I can. Like, obviously you have to have some type of objects to manage your data, and that's one of the things that I do I struggle with in JavaScript. Again, going from statically typed languages into JavaScript is a mental challenge. But one of the things I find is it bites me once in a while, but I've also discovered that most of the time, the types that I'm defining now, and if I look back around my career, the types that I've been defining historically, they get used for 1 or 2 functions, and that's about it. We go through a lot of ceremony to tell the compiler, to tell the system what the shape of our data is, to use it for 3 or 4 or 5 lines and then never look at it again. So I find that for the most part, I can get away with just using the more dynamic objects, treating them as dictionaries as they're intended. As far as working with classes, I think classes are an abomination. I have used them, usually to the extent of exposing something like event emitter, or there's been a couple things like if I want to extend a stream or provide some type of custom stream functionality where it's easier to more naturally extend that type, then I'll do that. But by and large, I go back to my classical traditional environment. Statics are evil. No, statics are awesome because by their very definition, they don't have shared state. Right? So if I have a static function, I'm going to be giving it the things that it needs to do its job, and it's going to be returning something. I'm also as in the functional side, I'm going to make sure that unless I have good reason not to, my functions are going to return something, because that's what helps us with our composability. That's what allows us to more easily test. I'm giving you as a function everything you need to do your job, and you're going to give me something back. So now I can plug in that things like as I've gone down this route, I find things like dependency injection in those frameworks are so overkill, because what is it really doing? It's injecting a function somewhere ultimately. Mm-hmm. So why don't I just give it the function that it needs to do its job and forego all of the complexity? You hear in functional programming circles talking about how async is inherently easier. Well, I'm working in JavaScript, everything's mutable, but through applied discipline, I can make sure that I'm not sharing objects. I can make sure that I'm not changing objects. I can put some enforcement around it, like object freeze, and use some of the reflection capabilities to define immutable properties. By and large, though, I find that just through some basic discipline, if I'm not changing those objects, well, guess what? I have multiple instances running. I'm handling HTTP requests. They should be isolated in general anyway. Maybe I need to throw something in a cache somewhere, but I'm not going to change that, and I'm going to look it up when I need it.
Okay, that was actually going to be one of the next things I was going to ask about, was the immutable data structures, because I know in JavaScript it's really not designed to allow for the immutability. They do have, you have object freeze, but even then, some things aren't quite frozen.
Right.
Have you ever used any libraries that provide the immutable data structures?
I actually have not. I've used some additional like async capabilities for workers and whatnot, but by and large, I have not found it necessary to bring in any of the more dedicated, immutable types of data structures.
Okay. So I know that originally in the way back when functional was created with languages like Lisp and whatnot, the reason why it didn't quite catch on as just the way to do things was that it was inherently slower on the processors of the day. Is that still the case? Is there a performance concern with functional versus other programming methods?
There's always a trade-off. I have found in my experience, whether it's working with functional flavored JavaScript or F# or functional flavored C#, that the performance differences have not been enough to matter. And if you're caring about the extra few milliseconds that it takes to allocate an object somewhere, you're probably in the wrong language anyway.
Well, up until recently, it's the only language if you're doing web.
The application, like, I'm not doing high frequency trading, right? I'm playing at people standing in line at the grocery store. So, I mean, I'm handling a good number of requests. The performance has not been an issue. Good. But again, it's a trade-off, right? There are times where you would definitely want to, if you're working with large data sets in memory, you're probably going to want to reuse some of that allocation. And functional does not say you can't do that. Functional says you keep it isolated.
So with OO, there are books upon books upon books of programming patterns. Are there similar patterns that can be applied to functional that will make it easier, or is it kind of every developer for themselves?
Well, I think there's, and I wish I could go back to who actually coined the phrase, but in recent years, I've seen pop up more than a few times that a language pattern is an identification of a deficiency in the paradigm. And so, yes, I mean, absolutely, there are going to be patterns. Like one of the patterns that I fell in love with F# and has flavored everything I've done since, be it C# or JavaScript, is the pipeline pattern. So that goes back to Unix commands, right? So I use that heavily. It's really, in terms of patterns, I don't necessarily have the names for them. I'm sure there are people who are far more familiar with the underlying theories and principles and lambda calculus than I am, that would have more formal definitions and names around them. But for me, it's there are things. There's partial function application. There are curried functions, those types of things. But those are really just naturally part of the language most of the time. And so I don't really necessarily think of them as patterns in like the singleton or the facade of variants of or flavors of design patterns, like the Gang of Four stuff.
Okay. Let's see. You had mentioned that you work, or well, so far you have really only stated that you're doing work in Node. Are you also doing the web client-side JavaScript, or?
So I primarily focus on the back-end code. We do have React components and whatnot. So our front end is a React application, and we have not implemented some of the things that I'm doing on the Node side in the React side. I don't think that there would be any problem doing that. But again, to your point earlier, React is really already a very functional way of doing things.
Yeah, it certainly attempts to. On the server side, so one of the reasons why I was asking that is on the client side with React, Facebook came up with the Flux pattern, and then the popular library for that is generally Redux. Are you using a similar method for communication within the server side, or do you have something else that you're using?
No, we don't have. I do as little state sharing as I can, and in fact, if I had to go back and do greenfield development on our web application, Redux would not be part of it. So I would completely avoid that. Like I would, as an experiment, I've even thought about going down and just looking at how would I implement this in Elm. because I find Elm to be fascinating. But I do have some things and it's more in the interests of avoiding trips to the database and various scans. So I do have some things that are more complex queries that I throw into a cache, and I do have some cache expiration. But by and large, I'm doing everything I can to follow the notion that an HTTP request is independent of all other HTTP requests, and get the data as I need it and dispose of it as needed.
Okay, so you're trying to just go straight down, come straight back up, hand it back to whoever asked for it, and call it a day.
In the interests of outward scalability, I'm not sharing anything more than I have to beyond a shared cache. So that means if we need to spin up another instance in our hosted environment, we spin up another instance and that's it.
And you had mentioned that given the state of Node and given the state of JavaScript, a lot of what you're relying on right now is discipline, following the patterns and practices that you've put forth for the application that you work on. Is there anything in place other than maybe a code review policy or threats of violence to make others on your team adhere to those same disciplines? Or what about bringing on new developers to the team?
So it's funny you asked that, because I've actually just gone through this. Now, code reviews are going to be the first gatekeeper. But what's interesting is we just brought on an intern, and he and I sat down and started going through this, and I started showing him some of the functions and the way that the code is organized and the way that we're using some of the things like pipelining in JavaScript. He was able to sit down at a code base he's never seen before, look at a function, figure out where look at the system, find the entry points, follow the code, and understand looking at a particular function because of that pipeline pattern, follow the steps because they're almost English-like, and understand exactly what was going on. So an intern going into his junior year at Indiana University, at a university in Indiana.
So making something
School. And he's not there.
So having made something that is easily understood, easily read, and reads like a sentence was useful and understood by someone that was absolutely new to the code base.
Exactly. Yep. Comes right in and understands exactly what, because the way that the code is organized, we follow certain organizational patterns, we follow certain naming conventions, and the way that the code itself is structured into that pipeline gets rid of all the extra noise and allows us to follow almost a checklist of the steps that are happening in a particular function.
So in my experience, that is something that takes an extreme amount of care. How is the maintenance of the code base? Is it a lot of effort to keep up that consistent structure and readability?
No, I have not found it to be, and whether it's this project or other projects that have followed a more functional structure. I also find that ultimately, and there's some documentation online, you'll find that a lot of things that when people start going down this functional path, this path to functional programming, they realize that they're writing less code in general, and that the code that they write is ultimately more meaningful and more reusable. So therefore, it's easier to maintain over time.
So if your company is paying by lines of code, don't go functional.
Exactly.
So are there any resources out there that you might recommend for functional programming, or for going down the road of functional flavored JavaScript or anything like that?
So the only thing I can really recommend is because it's the only thing I really have the experience with, is kind of the path I took, right? So one of the things that lured me to F# back in the day when I started down that path was, rather than trying to bite off an entirely new ecosystem and paradigm at once, like F# is inside of the .NET ecosystem. So I don't need to learn new editors. I don't need to learn new libraries. So I started off learning some of the concepts in LINQ. I learned what higher order functions were because of LINQ. I understand more about what composability is because of LINQ. So if I already understand those, I'm working inside of a particular environment, rather than trying to build out a whole bunch of extra things. Just stick within that environment. So if you want to learn functional programming and functional first programming, where you're not necessarily needing to go like all in on functional, where you can use the pieces that make sense, and like it did for me, jumping into F# was a natural transition. Once I started understanding those, it made it much easier to more broadly apply the paradigm to what I was working on. I would say for resources, I'm like, whatever Microsoft's calling it, I'm still stuck on MSDN. Docs.Microsoft, it'll always be MSDN to me. So, there's a lot of good resources there. There's books on Link that I think are great foundational pieces for functional programming, for F# specifically. There's F# for Fun and Profit website. There's I wrote a book on the book of F# for F# number of years ago. I think most of it's still relevant. It's been a while. I've been out of that circle for some time, but there's a lot of good resources online. I just don't necessarily have them handy at this point.
Well, great. We'll get some of those links to those in the show notes as well, and we'll get those out.
So one of the things we like to ask every guest is for them to share their wisdom with the other developers that are out there. Is there anything that you would like to say to new developers just getting started, or even developers who are trying to jumpstart their career and take it to the next or advance to the next level?
Sure. And I think this actually comes directly from my transition into the functional world, is I didn't really understand this earlier in my career. And when I started realizing this, everything changed. And that is to learn. It's actually twofold. It's one is to think about things in terms of the input and the input and the desired output, right? I mean, that's a natural side effect. That's what functional leads you to. But one of the other things that functional naturally leads you to, and I really wish that I would have had this in school, and I tell all of my junior developers the same thing, is learn to solve the problem in general. Don't go for the specific problem, because you're going to solve the same problem over and over and over and over. Understand the pattern. When you can understand the pattern and you realize that you've already solved it once before in just some slightly different way, well, let's go look at that solution and understand how does that solution apply to other things. And if you can do that, you'll find yourself writing more maintainable code over time. You'll also start being able to apply that type of thinking to other aspects of your life and not just code.
All right. And if somebody wanted to try to reach out to you, maybe discuss functional a bit more, do you have any social media accounts that would be appropriate?
Yeah, I'm Dave Fancher pretty much everywhere. I generally avoid Twitter these days, but LinkedIn is probably the best one, so you can find me there. Facebook, I tend to be a little bit more active, but LinkedIn is probably the best one.
All right, Dave. Really appreciate you taking the time to speak with us today.
Hey, no problem. Thanks, guys.
That was Dave Fancher. Dave is the lead software engineer at Vibenomics, speaker, blogger, author, and former Microsoft MVP.
If you like this episode, please like, rate, and review on iTunes.
Find show notes, blog posts, and more at sixfiguredev.com.
Be sure to follow us on Twitter and catch us live each week on Twitch at sixfiguredev.
This has been another episode of the Six Figure Developer Podcast, helping others reach their potential. I'm John Calloway.
And I'm Clayton